Okay, let me start recording first. Okay. Today we're going to start with polynomials. In polynomial functions are functions in the form of f of x equal an to the power an x to the power n plus an minus 1, say x to the power n minus 1 plus a 0. Okay, what does that represent? an minus 1 and an minus 2 and so on and so on. All of these represent the coefficients of the terms that they are in. Okay? N on top of the x represent the exponent of that of the x on the top. In order for this to be a polynomial, n is a non-negative integer. When we say non-negative integer, we're saying n can be anywhere 0, 1, 2, 3, 4, 5, as long as it is a counting number or a whole number, and it's not a fraction or decimal or any other form of number. So it has to be a positive or non-negative integer. In this case, n is the degree of the polynomial. Now notice n here, exponent n, and here exponent basically n minus 1 or what have you. And then as we go on, will be n minus 2, n minus 3. So n is the highest exponent of the polynomial given. So we look at the term with the highest exponent, and therefore that exponent will be the degree of the polynomial. Okay? An is the leading coefficient. An, notice, an is the coefficient of the term with the highest exponent. Okay? So an would be the leading coefficient for this particular polynomial. Okay? Let's take a look at some examples. Okay, so we're done with this. Let's go ahead and erase these. Don't have too much space on the board. So let's do some polynomials and determine the coefficient of those and the degree and the leading coefficient of those exponents of polynomials. So let's consider first f of x equal, say, 3x squared plus 2x minus 4x cubed plus 3. First, is this a polynomial? The question is, now we need to look at all the exponents of the x's, right? None of them is a fraction, none of them is negative, so therefore all of them are whole numbers, so therefore it is a polynomial. Yes? Now, what is the degree of the polynomial? Degree, then we take a look at, again, we take a look at all the exponents given. This one is a 2. This one has 1 exponent. This one has an exponent of 3. This one doesn't have an x, means it has an exponent of 0. Therefore, the highest exponent in that is 3. So therefore, this is of a degree 3. Okay? What is the leading coefficient? The leading coefficient is, now we already determined what the degree is. Now we're going to take a look at the coefficient of the term that has the exponent 3. And we can see that the coefficient is the number in front of that, in that term, before the x. And in this case, it is -4. So the leading coefficient is -4. Yeah? If I say I put a negative here, so then this is not a polynomial anymore. Why? Because the exponent is negative. Let's take a look at another. Consider, for example, f of x equal 2x plus 3 times x minus 4 times x squared plus 5. And again, we're also interested in finding out the degree and the leading coefficient of this polynomial. It is a polynomial. All the exponents are positive. Outside are positive as well. So therefore, it is, non-negative integer. I want to say positive. Okay? So therefore, it is a polynomial. What degree does this polynomial have? And how do I determine its degree? One way is to multiply it out, make it look like this, and then figure it out. But that's a lot of work. We don't like to work too much. So let's see how we can figure it out without having to do all of this multiplication. Now notice, we are interested in the x with the highest exponent. Yes? So if I were to multiply all the x's, I will get that. So I'm going to look at every factor and look at the one with the highest exponent and consider that only. For instance, we have here 2x. So first is 2x. Okay? In here, we only have x. In here, we have x squared. Now, if I were to multiply these, what do I get? Okay. 2 times 1 times 1 is 2. X times x squared is x to the 4. So therefore, we get 2x to the 4. The degree is 4. The leading coefficient is 2. Now, you guys know how to multiply a variable? What do you do when you multiply the variables? How did I get a 4 over here? I added the exponent on the axis, right? All right, let's go ahead. Before I continue with this one, let's go ahead and refresh a little bit on multiplying variables, and then we go ahead and continue with that. Okay? So let me erase this. But in any case, this was easy. You multiply. First, when I say x cubed, What does that represent? X cubed is the exponent represent multiplying the base of that exponent by itself 3 times. And in this case, the base is x. So I'm going to multiply. So this represents x times x times x. Okay? So now when I say, what is x cubed times, say, x squared? If I go back to the representation of each one, in order of operation, says you have to do exponent before you do the multiplication, correct? So to do the exponent, this means x times x times x times, this means x times x, correct? So now, when I multiply these, I can write them in this form. Instead of x times x times x, we say x cubed, and x times x times x times x times x is x to the power 5, because x multiplied by itself 5 times. Or we could have simply, at the beginning, say, when you multiply these, you add their exponent. 3 plus 2 is 5. So rule number 1. We have x to the power some number multiplied by x to the power some number. The result is x to the power the sum of those numbers. And of course, notice the base are exactly the same. Clear? The base must be the same. So if we have different bases, we can multiply until determine what each value is. Now, consider, say for instance, x to the power 4 now divided by x squared. X to the power 4 divided by x squared. What do we get? Well, again, we're going to do the exponent first. It's x times x times x times x, where x, in this case, we consider that x is a non-zero number. It's not 0. It's any other number, but 0. And then on the denominator, we have x times x. So we do have multiplication on top. We do have multiplication on the bottom. So that means in a fraction, we can simplify as long as the numbers are not 0. And we just said x is not 0, so I can simplify by dividing both by x. So x and x gone, x and x gone. We're left with x times x, which is x squared. Or in subtract or in division, we could have simply said 4 minus 2 will be 2. So if I'm multiplying, I add. If I'm dividing, I subtract. So rule number 2 is, if we have x to the power m divided by x to the power n, I'll be x to the power m minus n. So let's take a look at another rule. Suppose we have x squared cubed, where we have simply double exponent. Yeah? But to evaluate this, we first need to evaluate the exponential terms. So I'm going to evaluate the outside exponent. And what does the outside exponent say? Well, it says you multiply everything in the parentheses how many times? 3 times. So that's going to be this, first parentheses, second, third. Now what's inside the parentheses? X squared. So that's x squared, that's x squared, that's x squared. Clear? So that is What is x squared? X times x times x times x times x times x. How many times do I have the x there? So that's x to the power 6. So we could have multiplied 2 times 3, we get 6. So rule number 3, x to the power m to the power n equal x to the power m times n. Okay with that? All right, let's go to one more rule. And the rest of the rules, we go along with it when we get to it. Suppose we have x to the power 0. What's x to the power 0? 0. Anybody else? Nobody wants to say anything? All right. How do I get x to the power 0 in the first place? Yeah. Well, notice we do have a subtraction here, don't we? With the subtraction, you can get a 0. Correct? Because we're subtracting hopefully 2 positive numbers. Okay, consider this. So if these two terms, or if these two numbers were the same, we will get x to the power 0. Yeah? So let's put a scenario. So we have x to the power m, x to the power n. We need m and n to be exactly the same. So let's say x cubed over x cubed. And assuming x is not 0, what does that give me? What's x cubed divided by x cubed? It's not a trick question. Let's do that again. What is 5 divided by 5? 1. Why? Because you divided a number by itself. And what's 10 divided by 10? 1. Because we're dividing a number by itself. What are we doing here? We're dividing a number by itself. So we get what? We get 1. Remember, x and 1 are not the same thing. X is a number that could be any number. 1 is strictly 1. So if I say x is 2, if I say x is 2, 2 cubed is 8, 2 cubed is 8, I end up with 1. I don't end up with 2. Right? So anytime you divide a number by itself, you get a 1. Now assuming that number is not 0, because we can't divide by 0, right? All right. But then again, we just said if we have a division, we can simply write this different way. We can say x cubed over x cubed is also equal to, based on the rule of the division, it is x to the power 3 minus 3. That's equal to x to the power 0, right? But these two are the same, aren't they? Then the answer must be the same. Because you cannot divide two numbers and then get total 2 different answers. So those answers must be the same. Then x to the power 0 must equal to 1. If x is not equal to 0. So now, any number other than 0 raised to the 0 power equal 1. Why? Because it's like you divided that number by itself. Clear? So if I have 1000 to the power 0, that's 1. Or if I have a negative 2 to the power 0, that is 1. Because the 1000 to the power 0 means 1000 over 1000 if you want, which is 1. And negative 2 to the power 0, same thing as saying negative 2 divided by negative 2, simplest form, right? And that's still going to give me 1. Yes? So rule number 4, we have x to the power 0 equal 1 if x is not equal to 0. X to the power 0 equal 1 if x is not equal to 0. If x to the power 0 equal undefined, if x equals 0. Now when x is 0, then the statement is undefined. We click on that. Hopefully that should give you some kind of review or some kind of ideas of dividing and stuff, because we're going to run into these sooner or later. Okay. Let's go back now. Let's go back now to polynomial. So now find the degree of this polynomial. So this way you get to use what you just got. Okay? Again, we said we're only interested in simply the degree of the coefficient. So imagine if you were to go ahead and expand all of these, that's going to be a whole lot of multiplication. We don't want to do that. So our only interest is knowing the degree. So therefore, we're going to go ahead and take only the element that will help us to get that answer. So we're only interested in the highest exponent of x and its coefficient, correct? So in every factor, I'm just going to look at the term that has the highest exponent of x. In the first term, first factor, we have how much? 2x, yes? So I'm going to put 2x. Unfortunately, we do have an exponent outside 2, right? So I'm just going to put that exponent. Okay? For the second part, we have x squared, and we also have exponent of 4 outside. And in the third one, we also have 2x, but we have exponent of 3 outside. So far, so good. Now let's evaluate. Now here, one rule I didn't put is if we have x times y to the power some number, that's going to be x to the power that number times y to the power that number. Another way, the number will be distributed for both exponents x and y. So let's take a look at this one. This one means what? 2 squared, yes, times x squared. What is 2 squared? 4 times x squared. Times. What is the result of x squared to the power 4? Which rule does this apply to? First, second, third? Which one? Third rule. So what do I do with the exponent here? Multiply. So what's 2 times 4? So that will give me x to the power 8. Yes? Now, this one also, we apply this one to it. Correct? Because it's more than one term. So first, we're going to take 2, raise it to the third power, then we get 8. And then x raised to the third power, we get x cubed. So now when we multiply these, we simply multiply the numbers and then we multiply the variables. Multiplying the numbers, we get 4 times 8 is 32. And let's multiply the variable. X squared times x to the power 8 times x cubed. So we're gonna follow the first rule. So what is the result for all of these? X to the power 13. And therefore, this polynomial given up here is of degree 13 and a leading coefficient of 32. Okay? Now, well, that wasn't part of our lecture, but we did that. It's all going to be kind of like, I mean, all of these not part of it. This was, but those are not. All right, so let's go ahead and take a look at how the graph of a polynomial, simple polynomial, looks. Let's take, for instance, f of x equals some x cubed. F of x equals some x cubed. And to graph this, we're gonna take a value for x. We're gonna substitute it into the function and figure out what the value of the function is. So first, I'm gonna do the following. If x is 0, then f of x would be substituting 0 and x cubed. We get 0. Okay? Now, suppose x is negative 1/2. X is negative 1/2. If I substitute negative 1/2 in here, so it is multiplying negative 1/2 by itself 3 times. That's going to be a negative, and then 1/2 times 1/2 times 1/2 would be 1 times 1 times 1 would be 1, and then 2 times 2 times 2 would be 8. So that will give me 1/8. Okay? How about it was 1/2? Same thing except not negative. Yes? Now if x is 1, then we end up negative 1, we end up with a negative 1. And if it's 1, we end up with 1. And if it is negative 2, it's going to give me negative 8. If it's 2, it's going to give me 8. Now I'm really interested a little bit in this area as well. That's why I took small numbers there. So go ahead and identify how things happen. So I'm going to choose 1 over here. So a negative 1 over here. Let's say 8 is up here. Let's say negative 8 is down here. And let's see what we can do with the graph. Well, we have a 0, 0 right there. Let's bring this a little bit in. Okay? And 1, 1, maybe about this is about 1. And this is about 1 there. And then the 2, a negative 2 here, negative 8 there. And then the 2 with the 8 there. So let's graph this. So we're gonna go through this point. Oh, one thing I haven't done yet. I haven't done the fractions. So when x is 1/2, this is kind of 1/8 right there. Negative and negative. Good. I'm just going to make it back. Now let's go ahead and graph this. Okay, it looks like that. So once again, okay, let's do one more thing. Next to it, instead of x to 3, let's put x to the 5. Is next to it, let's put x to the 5. What do I get with x to the 5? On the 0, I still get a 0. But on the negative 1/2, I'm going to get negative 1/32. Because if I take 1/2 and multiply by itself 5 times, I get 1/32. With this one, I get 1/32. On the 1, I still get 1. On the negative 1, I still get a negative 1. On the 2, negative 2, I get a negative 32. And on this one, I get 32. That's too far away for me to graph. So I'm going to ignore the 2 and negative 2. So let's deal in this range over here. Notice, at the 1, we're going to get a 1. At 0, we're getting a 0. Negative 1, we get a negative 1. Yeah? However, what happened in there? This is 1/8. But this, the other one is 132. Is 4 times smaller. So I'm going to get like down here. And on this side, I'm going to get here. So this is how the graph is going to look like. In this portion, and then it's going to go up, it's going to go down. Notice what happened here. It kind of like squeezed in. It become a little bit more flatter, if you want. Correct? What happened if this was x to the power, say, 7? It will even get what? More flat, because this point is going to be down here, this point is going to be there, and I'm going to get it closer to 0 as I go. So between 1 and negative 1, the graph is kind of like settling down on close to 0 all the way. Yeah. But they all look the same. They still start here, end up there. Correct? And so on. Okay. So 5, 7, 9, they all look the same, except what's happening is you're getting more and more toward a straight line over here. It's never a straight line, but you're getting more and more toward it. Between negative 1 and 1. All right, let's take a look at another type of graph. Now let's take a look at, we did the odd ones. Let's see what happened with the even ones. So let's take x squared. And since we already learned our lesson, let's only take numbers between 0 and 1. Between negative 1 and 1. And see what happened with those. Because those are our interest. In this case. So now let's do x squared. If I do x squared, we've seen that before, right? If it's 0, then we get a 0. If it's negative 1, we get a 1. If it's 1, we get a 1. If it's negative 1/2, I get 1/4. Right? And if it is 1/2, I get 1/4. So let's see. Now let me make the 1 big. This is the 1. This is the negative 1. Right there. And on that say this is a 1, this is a. So here we have a point right there, and here we have a point right there. It's going to go by 0, correct? -1, give me 1. Okay? The 1 gives me 1, the 0 gives me 0. Now 1/2 here gives me 1/4 here, about that much. So 1/2 here give me about 1/4 here. And when I graph, the graph is going to go up and going to go up. Again, it is still a smooth graph. It's called continuous. And one thing about this, notice what happened when the function was up. We were starting at the bottom, right? And ending up where we're on top. But on this one, we start on top, we end up where? On top as well. So let's see what happened with x to the power 4. Well, if we have x to the power 4, when x is -1, so this is still 1. When x is 0, this is still 0. When x is 1, this is still 1. So in these points, we are still wherever we are. So far, so good. What happened on these points? In the middle, if I take 1/2 and I raise it to the 4th power, I get 1/16. Now, I need to divide this part into 4 parts. So now the 1/4 doing that, and it's doing that. So notice what happened in here. It started getting what? Start getting a white. First it was like a perfect ball, but now it started getting a ball with a base on it. What happened if this was 6? It's going to be the same thing, but it's going to hit that closer to 0. Going to go like this, and now it's going to even be what? More straight as that. Yes? And those are all the even function. They have one thing in common. They start up, they finish up, right? Or basically, if they start down, what happens to them? They finish down. Why? Because if I flip this over, what's going to happen? Multiply by negative, and this is going to be here. This part is also going to be here. So odd function start in one place, terminates in another, but even function start in one place, terminate in the same place as well. Okay? So it starts high, it ends high. If it starts low, it ends low. Let's put some rules for those. F of x equal ax to the power n. This is the general form of the basic polynomial function. Say if a is positive, n is odd, then the graph look like that. I'm just gonna show it like this. Now, we know it's odd. What has happened to the odd? It starts in one place, it terminates in another. Now, you don't have to memorize this. I'll show you how you do that to determine where you start, where you end. Notice, this graph depends on the x value. Yeah? The x value on this side is negative, correct? So if I take negative and I raise it to the odd power, what do I get? Negative or positive? Now, negative to odd power or exponent is negative. You take negative, you raise it to odd power, you get negative. If you get negative, you raise it to an even power, you get positive. Yes? So let's see what happens. In here, n is odd. Yes? In this area, x is negative. So I take a negative number and I raise it to an odd power, I get negative. Correct? And I multiply it by a, which is positive. So that means, oops, that means I'm getting a negative answer. So I'm here. Yes? The value is negative. We're done here. And then just, you know, it's odd. So you're going to end up on the other side. So if A is positive, if A is negative, and is odd, what happens? Now again, negative on this side. Negative to odd power is negative, times another negative from A will make it positive. So you're going to be here, you're going to end up down here. Okay? If A is positive and is even, then the graph looks like this. Again, on this side we have negative, yes? But then negative to the even power is positive, and positive times positive gives me a positive in there. This is even, it must end up in the same area. Correct? So what happens if we go, if A is less than 0 and N is even, then the graph is going to look like that. Again, we're looking at negative. Negative to the even power is positive. Positive times A, which is negative, gives me a negative down here. And this is even, so therefore I end up in the same location for even. Okay? We're going to do a quick graph and we're finished. Okay? However, this is not, these are the general base functions. Functions are not usually that even or that much. Let's go ahead and take a look at some function. Graph the following. F of x equal, let's say, 2x minus 1, x plus 1, and let's say times 2x plus 1. So it says graph the function. First of all, what degree is this? We have x, yes? We also have x. I'm only interested in degree, so I'm not going to worry about the coefficient. Okay? For now. We have x, we have x, we have x, so that's x what? Cube, so that's odd. 3 is cube. Yes? All right. Now the coefficient, is it positive or negative? Well, here we have a positive times positive times positive, so it's positive. So based on what we just did, the graph should look something like this. Comes down here, right? And it ends up there. So let's see how we graph this. First graph is, we need to figure out the intercepts. The x and y intercept. Yeah? What's the x-intercept? To get the x-intercept, you set all of these equal to 0, and then you solve them. First one, 2x minus 1 equals 0, means 2x equals 1. By moving 1 to the other side. means x equal 1/2 divided by 2. So the first intercept is right here. Oops, sorry about that. It's right here at 1/2. Okay? What's the second intercept? X plus 1 equals 0 implies x is negative 1. So negative 1 right here. And then we know the third one is 2x plus 1 equals 0. This means 2x is negative 1. Yeah? So that means dividing by 2, x is negative 1/2. So this is the third intercept right there. We already know the function. Where does it start? Start in here somewhere. Correct? When it goes up, what's going to happen? It's going to hit the first point. Correct? From here, it's going to do its job over here, whatever. Correct? But eventually, when it's done with this job, what's going to happen? It's going to come back over here. Correct? In this time, what's going to happen? It's going to do its job. Correct? And then what's going to happen? It's going to go up here. Now, as it goes up, it's going to continue. From here, it's going to continue. Notice where it starts. It started here, and where does it end? There. So that looks good. Yes? Now, the more point you take, the more accurate your graph is. We can say, for example, what's the y-intercept? We're just going to take the numbers. Negative 1, 1, and 1. If I multiply these, I get a negative 1. So the graph is going to hit that point. I'm just going to use imaginary situation and do. Yes? Now notice, this graph has one hump, one valley. So this is at least a third degree graph. The number of humps and valleys will tell you what is the least degree polynomial you have. Okay? A polynomial will have at most one less humps and valleys than its degree. So if a polynomial is a 5-degree polynomial, it will have at most 2 humps, 2 valleys, a total of 4. Yes? Now it could have 2, it could have, but it's still a total of how much? 4. It cannot have more than 4. If you have a function looks like that, yes? So how many do I have? 1, 2, 3, 4. So this is at least degree what? 5. This polynomial at least degree how much? 5. Now it could be like, say you have a whole lot of flattened over here. It's not like really hump. It's kind of like more flattened. More flattened means you have more than degree 5. Okay? You have more than 1 degree right there. So it will add up. But in general rules is, if it does have, say, 4 humps, it is at least degree 5. Could be degree 7. It could be whatever, or higher. Yes? And especially starting in one place and it's ending where? On another. Now, if I continue this like that, this is going to be even. Yes? It's got 1, 2, 3, 4, 5, so it's at least how many? 6. So at least 6 times. Okay? I think that's it for today. You guys have a wonderful day. I'll see you back on Monday. Okay.